is good. Okay. Well, let's start with prayer. Father God, I thank you for another opportunity to be with these dear students, both in class and online, and we commit this fourth session to your hand. I again ask your blessing upon all of us. Bless these dear students in their studies for this course or for any other classes that you are taking, and bless their families and their ministries for your glory. We commit our time into your hand, for in Jesus' mighty name we pray. Amen.
Amen.
Wanted to mention also that I mentioned that on the bulletin board, that if you have prayer requests, you can put that. There's a place for a prayer request. You can put that there and be more than glad to pray for you. For today, I wanted to first go over the quiz, some of the questions on the quiz, and talk about them. Let me see if I could go to here and then go here. How are you doing?
Doing good.
Doing good. Okay. Quiz number 2. I think I just wanted to work on those math questions. I think those questions about composite or prime numbers are pretty clear, unless you have a question about them.
Yeah.
No, okay. Let's work on these math questions. For example, this one, I believe that's question number 8. Let me just turn on my tablet. Right. One moment. Go here. All right. First, write the question. It says, let me write the question on a paper for myself, and then I will write it on a pad. Uh, 4 divided by 2 plus 7 minus 3 times 2. All right, so let me go to the stop share and go to another share screen here. Okay, the question asks us to evaluate this math operation. 4 divided by 2 plus 7 minus 3 times 2. Okay, remember from what you studied about the order of operation, division and multiplication have priority. So 4 divided by 2 is 2, this part, 4 divided. And 3 times 2 is 6, minus 6, and this is plus 2. Then plus 7, I bring this plus 7 here. So I have 2 plus 7 minus 6. 2 plus 7 is 9, minus 6 is 3. Okay? Do you follow me? Any questions?
I'm good. Yeah, I follow that.
Yeah, you're good. Okay. Then let's go to the next question that we have. Well, the next question, what mathematical operations do each of the first letters stand for? P for parentheses, E for exponential, M multiplication, division, addition, and subtraction. So we do first whatever inside the parentheses, exponent, we multiply, divide, add, and subtract. The other one that we have is 16 times 2 plus 4 minus 90 minus 3 times 2. So again, let me go here and clean up this place here. So we have 16 parentheses, 2 plus 4, and can you see these?
I can.
Okay, good. 2 plus 4 minus 90 minus 3 times 2. Again, first I take care of what's inside the parentheses, so I have 16 times 2 plus 4 is 6 minus 90 minus, and again I take care of this multiplication here. 3 times 2 is 6. Then 6 times 16 would be 96. Okay? So 96 minus 90 minus 6. Okay. 96 minus 90 is 6. 6 minus 6 is 0. All right?
Mm-hmm.
No, any question?
No.
Okay. Then let's continue. The other question asked from square root of 80 divided by square root of 5, and the other one, the square root of 48 divided by a square root of 6. So let's go to our tablet again and clean up here. So a square root of 80 divided by square root of 5. Remember I said when here is the same as this, when nothing is written inside that radical means it's 2, means that we are getting a square root of 2. It's a square root that we are getting. When they are the same, we can write it as this. We can write one big radical and put everything under that. 80 divided by 5. Because this part and this part and that part are the same. If I had, for example, the square root of 80 divided by cubic root of 5, I couldn't do that. They must be the same inside what I'm trying to get under. The index should be the same in order to write it as like here. Okay?
Okay.
Yeah. Now, so 80 divided by 5 is 16. Okay? Follow me?
How'd you get 16?
Okay. 80 divided by 5.
Okay.
5 goes to 8.
Okay.
One time. I bring the 0 down. 5 goes to 36 times.
Got it.
So that's how I got the 16.
Got it.
So then a square root of 16 can be written as 4 times 4. Yes?
Yeah.
Okay. Or 4 to power of 2. This gets divided by that, comes out of the radical. Actually, we don't need the radical anymore. So the answer is 4.
Okay.
All right?
Yeah.
Any question?
Nope.
No. All right. So let's do the other one. The other one that we have is square root of 48 divided by the square root of 6. Again, because the index here are the same, I can write it as one big square root of 48 divided by 6. Now, what is 48 divided by 6? It's 8. How do I know that we can divide it?
It's 48.
Oh, okay. I'm sorry. Like this. 48 going divided by 6. Oh, well, yeah, 6 goes to 48. It's just, I know it by memory, 8 times. So I have 8, put it here. And 8 is like 2 times 2 times 2. Or 2 to power of 2 times 2. Now, this part can come out of the radical because this 2 gets divided by the index, comes out. So the answer is 2 times square root of 2. Question?
No.
Okay, good. So let's go to let's see, what other question do we have here? Okay. For some reason, I cannot see the questions. Oh, that's funny. Okay, let me go here, maybe here. Yeah. Oh, okay. No, I can't see it. We have 6.9 times 10 to the power of minus 8 over 3 times 10 to the power of minus 2. All right. Okay, now let me write down the other question also to save time. It says write 0.000 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8, 9, 92 in scientific notation, and the last one is 1/5 plus 7, 8. Okay, let's do these. Okay. Here. Okay. The first question asked, we have 6.9 times 10 to the power of minus 8 divided by 3 times 10 to the power of minus 2. Let's look at each part separately. Let's first look at this part, okay? Remember we said when the base is the same, you just add the exponent or subtract the exponent actually. So that would be 10 to the power of minus 8 minus minus 2, okay? I have to take this minus 8 and subtract it from minus 2. So I have minus 8 minus minus 2. So I get 10 to the power of minus 8 minus time minus makes that positive, plus 2. So it's 10 to the power of minus 8 plus 2 is minus 6. You see that?
Yeah.
Okay. Then this part. 6.9 divided by 3. Now, I can just say by looking at it, it's when we have 6.9 going to 3. In order to get rid of this, I put, it's actually would be 2.3. I know it from memory. Because if you time 2.3 times 3, you get 6.9, you know. Or do you need me to show it to you, or can you see it's 2.3?
Mm-hmm.
Okay, it's 2.3. So the answer is 2.3 times 10 to the power of minus 6. If you want to write it in scientific notation, if you want to write it in normal, ordinary decimal notation, you have one decimal here and minus 6, means that the decimal must move this direction 6 times. So it goes 1, 2, 3, 4, 5, 6. I put a 0 here, and I get rid of all this, and I have to put 1, 2, 3, 4, 5. 5 0. So I'm sorry for being messy. It would be 0, 0, 0, 0, 0, 23. Do you see that?
Mm-hmm.
Any question about this? No? Okay. All right. So just remember what we did was we took the exponent part. We said the base are the same. We wrote it 10. Minus 8 minus 2 becomes 10 minus 8 plus 2, which becomes 10 to power of minus 6. And 6.9 divided by 3 is 2.3. So it's 2.3 times. You can either write it that way, or in a scientific notation, or in a decimal notation like that. If the question asks you to write it in a decimal notation, then it would be like this. And how do I know that where to move the decimal point? By this number. It's negative, so it moves toward this direction. Moves toward left of me. So I move the decimal, counting from here, 1, and then 5 more, and I put for those 5 places 0, and that's the decimal notation.
Okay.
All right, let's go to the other one. The other question asks us to write this decimal number in a scientific notation. Okay, there are 9 zeros. $92. Okay, so I want to move this to have a scientific notation. Means you move the decimal point from here. You want to move it all the way to here. So in order to do that, I need to multiply. I can write 9.2 times 10 to power of minus. How do I know it's minus? Because I'm moving the decimal in the right direction. When it's moving that direction, it must be negative. Minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Now you lost me, because if on the last problem when we did it, it was minus 6. We moved to the left. So why is it still negative and we're moving to the right?
Okay. If in a previous question we had remember we had we had 2.3 times 10 to power of minus 6. Okay.
Right.
All right.
Right.
Now I wanted to write this in a decimal. This is a scientific notation. I want to write it in a decimal notation. When it's negative, I move the decimal here that way. here is a decimal notation. I want to make it into a scientific notation. I move toward right.
Ah, okay.
But when I have the scientific notation and I want to make it into the decimal notation, then I have to move the decimal.
Got it.
Okay.
Got it.
All right. Then let's go to the last question. We have 1 plus 5 plus 7/8. Remember, we said when we have fraction, when you want to add or subtract, you need to find the common denominator, the common denominator. And in order to do that, you take the first fraction, 1/5. The rule, remember, you can, if you multiply a fraction, both the top and the bottom, the numerator and denominator, by any number, if you do for both top and bottom, it doesn't change its value. So, in order to make these have a common denominator, I'll multiply the top and the bottom by this, by second denominator, the second fraction, its denominator, by 8/8. Plus, and then for this fraction, I multiply the top and bottom, 7/8, by that denominator, 5/5. Now see what happens. 1 times 8 is 8. 5 times 8 is 40. Plus 7 times 5 is 35. 5 times 8 is 40. So I made the denominator the same. Okay, now I can just write 35 plus 8 would be 43/40. You can write it like that, or you can actually divide it, or you can write it because it's an improper fraction. You can say 43 goes to 40 one time. If you divide it one time with a remainder of 3, so it would be, I can write it also as here, 40, this comes here, and the 40 goes down here, the 40, I'm sorry, this is 40, and the 3, and the remainder goes here. So this 40 times 1 plus 3 become 43. So the remainder goes here, becomes a numerator. The quotient becomes the number here, and the divisor becomes the denominator. We can write it like that or like this, doesn't matter, 1/3/40. Okay?
Okay.
Any question?
No.
No, all right, good. So let's just clean here. And now we can go to our PowerPoint. Okay. We want to talk and study about fraction, percentage, and ratio. In actuality, they are the same thing. Fractions, we can show it in a diagram or write it as a number. The whole thing, the whole circle, 1/1. If I cut it into half, so I have I have one whole thing divided by 2. If I cut it into 3 parts, 3 equal parts, I have one whole thing divided by 3 equal parts, and I have to divide the rectangle also. If I have divided by 4 parts, so I have one part divided by 4, and so on. Okay. So I want us to just get a visual image of fraction. Yeah, is that clear for you?
Mm-hmm.
Okay, so let's move on. You know, we have a role slide covered, and in fact, let me tell you this section is very helpful for church ministry because it can give you, for your budgets, is very helpful, and for study of your congregation, like the fraction of the youth people, the fraction of single people, or divorced people. You can use this diagram to get a better understanding of the status of your congregation. Percentage, that's a sign for percent. Okay, percent is simply a ratio of some number to 100. The difference between fraction and percent is when we talk about percent, we always talk about 100. In fact, the word percent, cent means 100, per 100. Okay, we express number as a part of 100. We divide the numerator by the denominator, and you multiply by 100, then you put a percentage sign. If you want to move from, if you have a decimal number, you want to make it into a percentage, you move the decimal point 2 places to the right. If you have a percentage, you want to change it to a decimal, the reverse of the previous point, you move the decimal point 2 places to the left, and you remove the percentage sign. But let's look at some of the examples. For example, examples 1 and 2 on page 44 and 45. Let's go here. All right. Put this here. Oops. The camera moved. And let me go to the, so we want to make it page 44 and 445, examples 1, 2, and 3. Let me stop here, go to here. Okay. Example 1 and 2, it says expressing a fraction as a percentage. Express 5/8 as a percentage, for example. That's example number 1. Right here on the tablet. Example 1, page 444. So we want to express 5/8, which is a fraction, as a percent. We want to express that as a percent. So we divide the numerator by the denominator. 5 divided by 8. 5 goes into 8. I have to put a 0 and add 6. I put a decimal point because 5 is less than 8. I put a 0 here. And then 8 goes to 56 times, so I get 48, remainder of 2. Then I add another 0. 8 goes into 22 times, and 2 times 8 is 16. 16 minus 20 minus 16 is 4, and I put another 0. 8 goes into 45, 5 times, and remainder of 0. So the answer is this. First, you divide the numerator by the denominator, and the answer is 0.625. Okay? Now, you multiply that by 100. So if you multiply that by 100, that decimal point, you see the decimal point moves that direction. The number is becoming bigger by 2 places because 100 has 2 zeros. So this becomes 6. I move this decimal point here, here. The answer is 62.5. Are you following me?
Yes.
Okay. Then I put the percent sign. So the answer is 62.5%. 5, in other words, we say 5 is 62.5% of 8. That's what this means. Okay? Let's we wanted to do also example, page 445, example number 2. Let me clean up here. Okay, so we are on page 445, example number 2. It tells us, no, you are doing the reverse one. It says we have 0.47. This is a decimal notation. It says show that as a percentage. So what you do, in order to do that, you just move the decimal point or multiply this number of 0.47 by 100. And what do you get? This decimal point moves 1 and 2 places here. So you get 47, and you don't need to put a decimal point because there's no number after that. 47, that's it. And you've just put the percentage sign. Okay.
Okay.
Let's see what we have. Also, example number 3. Let's look at that one. Let me clean up here. Example number 3 tells us express each percent as a decimal. The first point, now I'm looking at example number 3. The first one is 19%. Now, here I'm doing the reverse of what I was doing in example 1 and 2. This is in a percentage. I want to write it as a decimal. 19%, it means 19 out of 100. Which means you just count from here, from right to left, and then put the decimal, 1 and 2. So I get decimal 119, and you can put a 0 here, and yeah, you don't need a percent sign. This is it, 0.19. Okay?
Yep.
Or the second example you ask, it says 180%. You want to change that into a decimal. 180%, and again, it again means 180 divided by 100. Again, start from the right and go that way to the left 2 places because 100 has 2 zeros. And then put the decimal. So you get 1.80, or you don't need to put a 0 after the decimal. That's it. And you get rid of the percent sign. Okay. No question?
No, sir.
Oh, good. Okay, we are moving forward. Let's go back to our PowerPoint. Okay. Now, so we did that, and then let's move on. Now, here's very, these things can become very handy in life. You can use this to figure out sales tax, sales prices, and income tax. Of course, with the change in the income tax rules, you got to follow and be updated with the current rules. But let's assume the rules are what we have in our textbook. You can figure out sale tax. Sale tax is you have a tax rate times the item's cost. For example, we will look at, let me again write these things down so that I will remember. Example 4, page 446. We can use this to figure percent and sale prices. Example 5 on page 446. And then there's a question right here too. Well, let's first go to our textbook and figure out these examples and go to our tablet again. So we go to page 446 and glasses on. Example number 4. It says, suppose that the local sale tax rate is 7.5%, and you purchase a bicycle for $894. How much tax is paid? Okay. So we have the tax rate as 7.5%. That means out of every $100, you have to pay 75 cents. Okay, the purchase of the bicycle itself costs $894. We want to know first how much tax is paid. The sale tax is, the formula is this, sale tax. As it's written there, tax rate, which is 75%, times the price of the item, which is $894. So 75%, if I want to write it as a decimal, it would be, remember, we move the decimal point 2 places to the left. So I move 1, 2, I put the decimal. So 7.5% is the same as 0.07. Okay, 0.7, 75% is 0.75. I'm sorry. Times 894. And if you do the multiplication, you get the answer. Here is 67.05. Okay? So this is how much tax you will pay to purchase a bicycle for that price and with this tax rate. Clear?
Yes.
Okay. Let's look at example 5 of the bottom of page 446 and then 447. It says a computer with an original price of, so here, so we don't get confused. We have a computer. The original price is $1,460. Is on sale at 15%. Okay, that's the sale rate. What's the discount amount? How much do you save by that? Well, in order to find that, you just multiply 1460 by 15%. Again, 15%, if I want to write it as decimal, I move toward left and put the decimal point. 15% is the same as 0.15. So I have to multiply 0.15 by 1460. And when you do the multiplication, the answer is 2.1 or $219. That's how much you will save in this sale. The second question is, what is the computer sale price? Then that's simple. You just take the original price, 1460 minus 219, and you get 1241. So this is how much you are going to pay, $1,041. Okay?
Yep.
All right. So let's go back to our PowerPoint. And I apologize for the assignment 4 and 5. I was waiting. I will grade it today. I was waiting. Some people were late. Just wanted to have everybody return it. And I will post the answer. Actually, you can find some of the answer in the next lesson already there.
Yeah, I posted mine, but I think I posted it in the wrong place.
No, I got yours. I got everybody. Okay, let's see, stop share. Let's go to the PowerPoint here. Okay, now I put a question here myself. A couch sales price is $400. Is going to back up to $450 on Friday. How much will I save if I buy it before Friday? And what percentage saving will that be? Okay. Well, how much I will save, you just take the current price, which is, if the price on Friday is going to be $450, the current price is $400. So if you subtract those, you get $50. This is how much you will save. What percentage of this, of the original price, you take the 50 by the starting value. See here, the question is this: what percentage saving would that be? So you have to find out how much you will save if you buy it before Friday. Divide that by the original price, the starting price, not the future price. Just be careful on that. And if you divide 50 by 400, you get 0.125. Or if you want to write it as a percentage, again, multiply this number by 100. So you move this decimal one place, two place, and then you put it here. It will be 12.5%. So you will save 12.5% of the original price if you buy it now instead of waiting till Friday. All right?
Yep.
Let's move on. We can write percentage as a pie chart. As I said, this can be very helpful for your own personal budget, for your church budget, or studying of your congregation. So the pie chart is, like a circle, so like a pie, and then you have different parts, different percentage or fractions. Church, 15% under 21, and these are the different ages. For example, a church or whatever. Okay, or you use this percentage and fraction to figure out tax sales and taxes. For example, computing income tax. Let's go to, let me write this down for myself. Okay. Where is this? Table 8.1 and example 6 of page 448. Yeah. All right. Let me go to our, okay. So I'm on page 448. Example 6. We want to compute taxes. This is a good example of how these can be helpful, assuming that the tax rules and laws are according to this, the time of this textbook. It says calculate the income tax owed by a single woman with no dependents whose gross income adjustment, deduction, and credits are given in a margin. If you look at your textbook on page 448, you see that green table on the margin that gives you all that information. use the 2008 marginal tax rate in table 8.1. So this is based on 2008 tax laws. Okay, so first you got to find the adjusted gross income. So just say adjusted gross income. Adjusted gross income is the gross income minus gross income is what you're supposed to get. Then, I mean, it just what you get your income in total minus all the adjustments. Okay. In this case, based on that table on the margin, the gross income of this lady was $62,000. And the adjustment is $4,000 paid to the tax-deferred IRA, so minus $4,000. Okay? So when we do the subtraction, we get adjusted gross income of $58,000. You know, when we do our taxes, our taxman, or if you're doing it by yourself, first you need to find your adjusted gross income based on whatever the law of the land at that year. Then you have to find what's your taxable income. The taxable income is adjusted gross income minus all your exemptions and deductions. Okay? These are, you know, the rules of the IRS. So the adjusted gross income is $58,000. Okay. All the exemptions, again, the single column in the table 8.1, that's where we get the exemption. If you go look at the table 8.1, the first column is for unmarried or divorced or legally separated single person. Exemption is $3,500. So that's where we get the number 3,500. Plus all the deductions. Now this differs from each person. You look at the, for this lady, again to that green table on the margin, and you find, you know, here, you know, for the mortgage interest, property tax, charitable contribution, and medical expenses. But the single column in table 8.1 shows that a 5450 standard deduction. A greater deduction can be obtained by itemizing. And it says can only deduct in excess of 75% of adjusted gross income. So that's based on the rules that are set on table 8.1. So you cannot go more than that. So the total, that's why the medical expenses are crossed. Okay? So when you add the other deductions, the total deduction that you can have is 12,100. All right. Now again, this is all based on the IRS rules and what we have. So we get 58,000 minus 3,500 plus the total deductions that we are allowed. This person is allowed to have $12,100. All right. And when you do all the addition and subtraction, the final answer is $42,400. $42,400. So that's the taxable income. Then in order to figure out how much taxes you owe, you have to go to that table. And if, you know, this is a little bit tricky, it says from 0 to 8,025 is 10%. Then from 8,026 to 32 550 is 15%, and so on and so forth. So that's why on page 449, you have these different numbers being multiplied by 10, 15, and 25% till you reach the taxable income of that lady. And you do all the multiplication and addition, and you get the number that it's written on page 449, 6943.75 cents. So the tax that this lady must be paying is this much: 6943, $6,943.75. But you know, we went through all these rules and we use percentage and and fraction to figure that out. I hope this is clear. Okay. This is based on rules of IRS. Is there any part of it that you need explanation?
No.
Okay. All right. Fortunately, I don't do my taxes myself.
I don't need. I somebody do it for me.
Yeah. Yeah. There's a person who his specialty is on doing taxes for pastors. Do you know that?
Mm-hmm.
Okay. Okay. Good. But that gives us an idea of what's going on. So let's go back to our PowerPoint. Now, another area that percentage and fractions are useful in order to find percentage increase or percentage decrease. If you want to find a percentage increase or decrease, you always first find the amount of increase, like that couch that I was talking about. Divide if it's increasing or decreasing, whatever it is, and then divide it by the original amount. For example, find the percent increase or the percent decrease by expressing the fraction in step one as a percent. You can do that. Let's look at examples 7 and 8. And go. Okay. Let's look at examples 7 and 8 on page 450 and 451. So let me go to our tablet again. And we want to look at pages 450 and 451. And look at the examples. Example 7 and 8. You see, in example 7, it gives us the chart of population of the world, and then it says in the year 2000, the population of the world was 6 billion. Now, they have done, and that data has come from the United Nations Family Planning Program. And then it gives an optimistic and pessimistic expectation for control of human growth, human population growth. Oh boy, probably they're talking about abortions. Mm-hmm. Now it says find the percent increase in the world population from 2000 to 2150 using a high projection data. So, from year 2000 to 2150, as you see that in the chart, it's moving from 6 billion to 30 billion. So in order to find the percentage increase for that population, in 2150, they say the population of the world would be 30 billion. So, and in the year 2000 was 6 billion. So in order to find the percentage increase, you take the future amount minus the original amount, and you find the amount increase, and then you divide that by the original number, which is 6. Okay, so we get 24 divided by 6, we get 4, or we can write that as a percentage, 400%. Multiply, if you multiply that by 100, 400%. So they are saying in the year 2150, the high projection of the population of the world would be, means that population of the world will increase 400%. Wow. Now, if we, same example, the part B says, use the data shown on the green low projection graph and find now percent decrease. Again, if you are finding the percent decrease, again, you find the difference, okay? If it's, it says in the year 2000 is 6 billion, 2150 is supposed to be 4 billion. I don't know how they figured that out. Then divided by the original. Okay, so we get minus 2 over 6, or actually, no, not minus 2. 2 over divided by 6, or 1/3, or this can be written as, if you divide it, you can get 0.33 1/3, or 33 1/3%, almost 33%. So they are saying the population of the world is going to decrease by 33%. All right. Let's look at a more practical example that we face. Is there a question here?
No, sir.
Okay. Let's go there to example number 8. It says jacket regularly sells for $135. Okay, that's the original price. The sale price is $60.75. After the sale price is $60.75. Find the percent decrease of the sale price from the regular price. So again, we want to find how much it has decreased from 135 to 60.75. We find the difference, and that's 74.25. Okay, then you take the difference, divide that by the original amount. What was the original price? $135. So you divide that by 135. When you do the division, you find the answer is 0.55. Or if I want to write it as a percentage, is 55%. So this is how much the price has decreased, 55%. Okay. All right.
Yep.
All right. So actually, I can say the sale rate is 55%. All right. Now let's move on. To our PowerPoint. Okay, simple interest. This is still the same, as in we change. Principal amount times the rate times time. Let's look at examples 1 and 2 on page 455 and 456. Okay. Okay. So example 1 on page 455, and I'm on page 455, example 1. All right. It says, again, simple interest, this is the formula. The amount, whatever it is, the loan or whatever, or deposit, times the rate, times time. PRT, principal, rate, and time. If you had deposited $2,000 in a saving account in a hometown bank, has a rate of 6% interest, giving you 6% interest back, find the interest at the end of the first year. So, what's the amount? $2,000. Times, what's the rate? 6%. Or 6%, I can write it. Remember, I can write it as 6 and move 2 places, the decimal, 1, 2. Same as this. Times, time is 1. Okay, so I have $2,000 times 0.06 times 1. When you do the multiplication, at the end of the first year, the interest you will earn is $120. Okay, let's look at same page, example number 2. If you have, again, IPRT. A student took out a simple interest loan of $1,800. So P is $1,800. For 2 years, T is 2 at a rate of 8% times 8%. Again, 8% is the same as 8, 1, 1, 2 decimal. So it's same as 0.08. And again, when you do the multiplication, you end up, the interest that will be added to his loan at the end of the second year is $288. That's something that the person needs to keep in mind. While we are here, before we go back to save time, let's do the other one on the next page. Do you have any question here?
No.
Okay. The other question is calculating future value. The formula on page, so I'm on page 456, example 3. Talking about calculating future value. In order to do that, the future value A, the formula is this, the future value A is equal, what, you see, it's simple, how much you borrowed in the beginning or how much you deposited in the beginning, plus that interest, which is PRT, okay? But I can write this, I can factor P out of here, which is same as P times 1 plus RT. You're following me?
Yes.
Okay. So this is the formula. The future value of whatever is the original price times 1 plus rate and the duration of the time. It says the amount borrowed, a loan of 1060 has been made at 6.5% for 3 months. Find the loan value, future loan value. So we write this here again. A is equal. P, it's 1060 times 1 plus the rate is what was it, 6.5%. 6.5%. Remember, we can convert that to decimal by moving the decimal point that direction 2 times. 1, 2. So it's same as 0.065. So my rate is 0.65. I need to make this. 1 plus, and then I put the parentheses here. This is the rate times, the time is, what was the time? They said, 3 months. Now, the time is in year. The unit of the time is year. So how many months are in the year? 12 months. I only want 3 months of that. So that's why you got to use this formula, 3 divided by 12. Because the unit for the time here is year. 3 months is only 1/4 of a year. Yes? Okay. Or I can write that, if I write it as a decimal, you divide 1 by 4, you get 0.25. Are you following me?
Yes.
Okay. So I have these two being multiplied. Put that in the bracket. And when you do all the multiplication and addition and everything, the final answer is $1,077.23. So if you put this much amount in a bank, after 3 months, this would be your balance. All right. Now, is there any question here?
No, sir.
Okay. Now, let's, while we are here again, in order to save time, go to the next page. Example 5 of page 457. Now, we want to find a present value using this formula that the future value is P times 1 plus RT. So actually what we are looking for is this P. We have to find P. It says you plan to save $2,000 for a trip to Europe in 2 years. You decide to purchase a certificate of deposit CD from your bank that pays a simple interest rate of 4%. How much you put in this CD now in order, how much must you put in the CD now in order to have $2,000 in 2 years? That's a very good practical question. You want to have $2,000 in future in 2 years. So the future value, A, is $2,000. Okay, we have A. What we don't know, okay, how much I need to put in the bank or in this CD in the first place. So we don't know the P. 1 plus, okay, what's the rate? 4%. I can write 4% as 0.04. Multiply by time. What's the time? 2 years. Okay, it's given me in a year unit, so I don't need to convert anything. So this is the formula. And I need to solve that for P. So you got 2,000 is equal. If you do all that here, all the calculation, that multiplication and addition, you get 1.08 P in order to solve that for P, you need to get rid of this 1.08. You divide both sides by 1.08. So this cancels. You get P is equal 2,000 divided by 1.08. And if you do the division, it's almost 1851 with some fraction, 852. Just 1851. So you need to put at least $1,851 so that at the end of the 2 years you will have $2,000 to buy your ticket. You follow me?
Yes.
Okay, good. So let's go back to our PowerPoint so we know where we are. So we did that. We did the future value. We did those also. Compound interest. That's something we haven't done. Compound interest loans, payment and mortgage loan and minimum payment traps on 4.6. You can look at these for your own personal review, but it's on page 460 to 490. I will not ask you on the test, but the formula on page 460, calculating the amount in account for compound interest paid once a year, you see, if you look at that formula at the bottom of page 460, it's the same formula except the t has become the exponent of that parenthesis.
Right.
Okay, and then now you can have a calculated situation that if you deposit, let's say, P amount of dollars at a rate of R, subject to compound interest paid n times per year, then the formula is different on page 461. Again, I'm not going to ask you this thing, but it's good for you to review, when you want to do some kind of investment or whatever. All right. Okay. Measurements. In the most part of the world, they use metric system, and in a scientific field, they also use metric system. That expression, King Henry died drinking chocolate milk, helps you to remember about kilo, hecta, deca, deci, centi, and milli. If the base unit, meter, gram, liter, you have here. Kilo means 1,000. So a kilogram is 1,000 grams. Hecta means 10. So, or means 10. So, and no, hecta means 100, I'm sorry. And deca means 10. So as we move from here to here, we are decreasing decimeter, centimeter, and millimeter. Yeah, this is bigger, this is smaller. All right?
Mm-hmm.
Now, you don't need to memorize this. These will be given to you. The key thing is when we want to convert measurement from one unit to another unit, the key is this. Given the unit of measurement should appear in the denominator of the unit fraction. So this unit cancels upon multiplication. The unit measurement that needs to be introduced should appear in the numerator. Now in order to understand this, we need to look at examples. Okay. So let's look at examples 1, 2, 3, and 4 on pages 503, 506, 508, and 509. let's look at example 1 on page 503. Okay, and again, let me go to the tablet. Okay, here it asks us, we are converting different units to other ones. For example, example 1 on page 503, the first part, part A, is asking us to convert 40 inches to feet, to measurement. And we want to know how many feet are 40 inches. The table, I will give you the table on, on the table on 502. It tells us 12 inches is equal to 1 foot. So 1 foot is equal to 12 inches. That's given. All right? Now, if I have all what I was saying in that PowerPoint on that slide was this. If I have 40 inches and I want my final result to be in feet, somehow I need to get rid of this here, the unit of inch. I have to multiply it by a number in such a way that the inch is in the denominator. Okay? So 1 foot is 12 inches. So I have to write here 1 foot is equal to 12 inches. You multiply it by a fraction, and you get the fraction from the table. 1 foot equal to 12 inches. 1 foot is equal to 12 inches. You multiply this, these inches cancel. You have 40 divided by 12, which would be 3.3. So the answer is 3.3 feet. Are you following me?
Yes.
Okay, so the key is this. I have inches. I put the inches here. From the table, we have this rule, 1 foot equal to 12 inches. But I need to put that 12 inches in the denominator so it cancels out. Let's look at example B. It says convert 13,200 feet, 13,200 feet to miles. I want my final answer be in miles, okay? So I need to multiply it by a fraction that has feet in the denominator. So these 2 feet can cancel. I look at the table on page 502. It tells me 1 mile is equal to 50 to 80 feet. Okay. When you multiply 13,200 feet by this fraction, these feet cancel out. So you get 13,200 miles divided by 50 to 80. When you do the division, you get about 2.5 mile or 2.5 miles. When you do the division, that's the final result. But the key again, you need to have that table, but when you write the fraction, if you want to convert this to a mile, you want to have, this is in feet, you want to have from the table, the feet to be in the denominator so they cancel out. Let's do, for example, another example. Let's go to page 506. Example number 2. it says convert 504.7 meter to kilometers. So I have 504.7 meter. I want the final answer to be in kilometer. Now, I look at the table. It tells me on page 504, you have a table. A kilometer, 1 kilometer is equal to 1,000 meter. So if I want the final result to be in kilometer, I need to have meter in the denominator and kilometer in the numerator. And it tells me 1 kilometer is equal to 1,000 meter. So these two cancel out. So you have 504.7 divided by 1,000. And whenever you're dividing by 0, it's very simple, because by the number of zeros that you have, you just move the decimal point. You have 3 zeros, so I move the decimal point 3 times toward left, so the final answer is 0.5047 kilometer. So 504.7 meter is equal to 0.5047 meter. Okay, I'm sorry, kilometer. Okay? Are you following me?
Yes.
Okay. Let's do another one. If we have number B, it says convert from meter to centimeter. We have 27 meter. Convert that to centimeter. So I want the final answer be in centimeter. So I need to multiply it by a fraction where meter is in the bottom. Now, 1 meter is equal to 100 centimeter. So these meters cancel out. So the answer is 2,700. Okay. Follow me?
Yeah.
All right. Okay, and let me see. Again, I think it's the same thing. But let's do one from page 508 and then one from page 509. On page 508, it says convert 8 inches to centimeter. So we have 8 inches, and we want the final answer to be in centimeter. I have to multiply this by fraction. That inches is in the bottom. I need to know 1 inch is how many centimeter, and that table on the margin gives me 1 inch is equal to 2.54 centimeter. These inches cancels. 8 times 2.54. When you do the calculation, the final answer would be 20.30 centimeter. And if we do one on page 509, says the speed limit on many highways in the United States is 55 miles per hour. How many kilometers per hour is this? So it tells us the speed limit is 55 miles per 1 hour. We want to know, we want to convert that to kilometer per hour. So I want to have kilometer per hour. That's my final answer. So I need to multiply this by a fraction that has meter at the bottom. Okay. Oh, I'm sorry, mile. This is a mile, not meter. 55 miles. So I need to have miles at the bottom. Now, 1 mile is, again, from the table, 1 mile is 1.6 kilometer. I multiply it by that. This mile cancels out by that. So I get the final answer is 55 times 1.6. When you do the calculation, you get 88. So our usual speed limit, 55 miles per hour, is equal to 88 kilometer per hour. So the key is this, that whenever you want to convert something to something else, the question asks you convert whatever unit to some other unit, inch to centimeter, for example. You need to have multiplied by a fraction where inch goes to denominator or miles goes to denominator, so it will cancel out with the original number that is given to you. And these fractions, it will be given to you from tables. Okay?
Okay.
All right. No questions so far?
No, sir.
All right, good. So let's go back to our PowerPoint again. All right, we did this. Now, calculating areas, these are again, it helps to know some of these formula, but you don't need, of course, a square, you take a side and multiply it by itself, you get the area of a square. Rectangle, width times height. Triangle is base times half the height. But the other ones, it will be given to you. The trapezoid, half a circle. R stands for radius, B is a base, H is a height, and so forth. The base and the other side, the front, facing the base in the trapezoid. If you have cases like this, like it tells you calculate this area, again, you look at the area and try divide it into known shape. For example, if I can draw a line here, then I have on this side a rectangle. So I multiply 7 by 3, 21 centimeter square is the area for this part. Okay? And then I look at this area here, this is another rectangle. Here is 3, here is 3, and so I have 3 here, and 3, so this side is 9. Now I need to know the height. I know from here, oh boy, okay. Well, I know it's 2, but okay, I know this side is 7, and 1, 2, 3, 4, 5, 6, 7. So each unit is 2. So I multiply 9 by 2. I get the area for here, 18 plus 21. And this here is 6 times 3, 18. So 18 plus 18, 36, plus 21, 57 centimeters square. Can you follow me, or do you need me to draw it for you?
No, that's good.
Okay, all right. Volume is always length times width, because that gives you the base area times height. Volume is answering this question, how many stacks do we have? So, one side is 3, one side is 5, 15 is the area of this side, but then if I want to volume, I multiply by 6, I get the whole shape. 4 times 6 times 5. All right?
Okay.
And other volumes, it will be given to you. But some of these, it helps to remember. Like if I have a cube, remember this one side, the area of a square is one side times itself. Now, Volume is how many of these areas can you fit into this cube. So you multiply it by another side, A. So the volume of a cube is A to the power of 3. If you have a rectangular prism, you find a base A times B, then multiply it by height. Cylinder, you find the area of a circle is the number pi times the diameter square times the height. And then height, you find PD square over 4 then times the height. It gives you the volume. H comes for the volume, but the square, the area is just PD square over 4. Okay?
Okay.
Now, changing unit, let's look at example on page 521 and 522. Examples 2 and 3. Let's go to page 521. Okay. Example on page 521. Example 2. It says an aquarium holds 0.25 cubic meter of water. 0.25 cubic meter. I'm sorry. All right, of water. How much does the water weigh? Now you look at the capacity, the table at the top again. We have 0.25 meter cubic. I want to change that to weight. I want to find the answer in kilogram. Okay, I need to multiply that by a fraction where cubic meter is in the denominator, so they will cancel. So I need to know 1 cubic meter is how many kilogram. And when you look at the table, it gives you 1,000. Okay? So when you multiply these together, these cubic meter cancel out. So you have 0.25 times 1,000. And again, when you are multiplying or dividing by 0, it's very easy. When you're multiplying by 0 and you have a decimal point here, you just move the decimal this way 3 times because we have 3 zeros. So you get 1, 2, and here. So the answer is 250 kilogram. Okay? Is that clear?
Yes.
All right, let's look at page 522. And again, it wants us to convert. Let me clean this up. It says convert 160 pounds to a kilogram. So I want to final answer to be in kilogram. From the table, I know 1 pound is 0.45 kilogram. So I need to have 1 pound in the denominator so they cancel out. And 1 pound is equal to 0.45 kilogram. Okay, these cancel out, so you get 160 times 0.45, and when you do the multiplication, the final answer is about 72 kilogram. All right?
Yes.
Or it says convert 300 grams to ounces. So I have 300 grams, but I want the final answer to be in ounces. So I need to multiply this by a fraction that says 1 gram is equal to how many ounces. And we know that 1 gram, we wanted to convert 300 grams, and, oh, wait a minute, to ounces. 1 gram, wait a minute. Well, okay, oh, we know that 28 grams, I'm sorry, 28 grams is equal to 1 ounces. So these grams cancel out. So you have 300 divided by 28. And when you do the division, it's about 10.7 ounces. All right?
Yep.
Okay. Then let's go back to our PowerPoint. Go 3 and everything, 520. All right. Temperature, we have 2 different units of temperature, Celsius and Fahrenheit. To convert from Celsius to Fahrenheit, we use this formula. This will be given to you. But if you, no, yeah, I will be given to you. You don't need to memorize. And to convert, let's do that first. To convert from Fahrenheit to Celsius, we use this formula. But let's go back here. It says, look at example 4 on page 524. Okay. So let's go back. All right. Example 4 on page 524, page 524, example number 4. If you have, says converting Celsius to Fahrenheit, the bill from your European vacation have you feeling a bit feverish, so you decide to take the temperature. The thermometer reads 37 centigrade. Should you panic? Okay, this is the formula. Fahrenheit is equal 9/5 centigrade plus 32. So it tells us the thermometer reads 37 centigrade. So the C is 37. So you have, this is the, for you, instead of C, you plug the number, you have 9/5 times 37 plus 32, which when you do the multiplication and division on this part, you get 66.6 plus 32. So this is 98.6 Fahrenheit. Okay, so it's pretty warm. Okay.
Okay.
So it's normal. So 32 centigrade is 98.6 Fahrenheit. It's the normal temperature of the body in centigrade. Or if you go to page 524, converting, other way around from Fahrenheit to Celsius, this is the formula. Centigrade is 5.9 times Fahrenheit minus 32. This is a formula. This is given. So it says the temperature on a warm spring day is 77 Fahrenheit. Find it in centigrade. So just put 77 here minus 32. and this would be 5, 9 times when you do 45, which would become 9 divided by 45 divided by 9 is 5. So the final answer is 25. So it's 25 centigrade. 25 centigrade is equal to 77 Fahrenheit. All right?
Okay.
Okay. Let me go back to our PowerPoint. We did that. Okay, we come to the end. Any questions?
No, sir.
You're ready? Okay. All right. Good. Well, I'm very glad. And so if you have no questions, we can finish the class. Oh, wow. We did good. All right. Then let me just pray and dismiss all of us.
All right.
Father God, again, I thank you for the opportunity to spend this time study about your nature, your universe that has such a beautiful mathematical pattern. I pray that we can use this knowledge about percentage fraction in your ministry for our own financial situation, church finances, and understanding our congregation better. I ask your blessing upon all of the dear students, both in class and online. May they be able to do a great job in their midterm. In Jesus' name, mighty name, we pray. Amen.
Amen.
All right. Good to see you, brother. God bless you and have a wonderful week.
God bless. Take care.
Take care. Bye-bye.